Hello guys, in today's video we're going to be making an earthquake detector. First, let's create a new file, brand new file called Earthquake Detector. And let's get started. These are just nothing, these are just links. No, not links. Later we will use these. First thing first, let's write import requests. Why do we import these? Because of we need to get permission to use their API or not. And then let's see, from datetime, import datetime. We import datetime because of we need to know the date. And then let's say def analyze. Let's create a new function called analyze. We create the analyze function because we want to run again and again. Or else if we write the code too long and then we want to run again, then we need to write again. That's wasting time. Let's say location. We need to know their location so we can know if they're earthquakes or not. Enter the location. Only city or country. And then we'll skip a line between, or else it will not be clear for them to see. You need to know the date too, so we can detect if there's an earthquake on that day or not. Enter the date. Let's see. Wait. Then we'll use an API URL to fetch earthquake data with a minimum magnitude of 1 or 0. The URL is over here, just like I said. We need to use this. Oops. And then oops, sorry. We don't need this. Then let's say the URL is finished, so let's request them if we're okay to use their API or not. Response equals to request sorry, there's more, I think. Yeah, there's more. then request.get URL. Fetch the data from the API. Check if the request was successful. Then, if the request is successful, we'll check if the request is successful. If response dot status code equals to 200. 200 means it's successful. If it's 200, then data equals to response dot JSON. We'll write this in JSON format. The data, and then filter earthquakes by location. Filter earthquakes equals a list. Earthquake earthquake 4. Features. Then if location dot lower in earthquake properties, and then the place dot low. So we're done with this. We have got list. Then we will check if any earthquakes match the location. If filter earthquakes, then if there are earthquakes on that day, then print f strings, and then we'll skip a line first. Earthquakes in location, in the location or the date, and then let's create a loop. Create a loop by counting how many earthquakes are there. For earthquake in field earthquakes, magnitude equals to earthquake properties and then we want to know the magnitude, so let's write mag. Then the placement equals to earthquake properties, then magnitude. Not mag, sorry. It's the place, so let's place. And then to get the UTC time stamp, we will use the UTC time to get rid of the time, and then make sure the API only uses the UTC time. These are notes, the things I wrote, like for example, like these notes. When you read back, you can understand what these codes are. Let's skip line. Time equals to date time from timestamp earthquake properties time multiplied by 1000. There's also time format like this. percentage M, and then percentage D. Space percentage H, percentage M, then percentage S. Next, if the magnitude is less than 4, then risk equal equals to the risk emo just like before. I'll copy this. You can get these emos or these links in the description. Then we'll paste this. Write low risk. This is low risk if it's less than 4. And then else if magnitude, if the magnitude is between 4 and 6, then the risk emo is equals to the yellow emo. This is medium risk. If the magnitude is equal to 6 or more than 6, then the risk emo is red. And then this is high risk. Low risk if it is more than 6. It's too dangerous. Else risk emo is not. This can't be true because if it is more than 6, then we're in higher risk. Just to make sure there's else. And then let's print the location